Hello Gaurav, am I audible to you?
Yeah, hello, good evening.
Good evening. Let's wait for 2-3 more minutes, then we will start the session.
Yeah, sure. Hello.
Yes, Gaurav. Yes, Gaurav, you were saying something.
Yeah, actually, I missed my this one first two assignment. So
Your mic is muted.
actually, I missed my two assignment, first two assignment. So I think now I can't submit now, na?
No, this is not related to assignment. This is means I will take a 2 hour session in which it will just help you in solving those assignments. It's not regarding
Okay,
direct
okay,
exercise.
okay, okay. Thanks. I'm sorry. You are not getting those assignments and submitting on time. Uh, Sivaraman. Okay, then we will start the class. Yes, yes. Have you submitted your assignments? When did you get those assignments?
Sir, I submitted on 7th, sir.
Okay. So I will start the class now. Hello everyone, my name is Sunny Kumar Sharma. I am a PMRF research scholar from IIT Kharagpur. And in this session, I will summarize the week three. I've already summarized week one and two, and I have given some questions and answers also that will help you in solving the weekly assignments of distraction engineering and PTF course of Professor Ibjit Rahman. So let's start the session now. So first of all, I will be just giving a recap of week one and two in 1-2 slides. Then I will be summarizing and giving question answers of lecture 1, 11, 12, 13, 14, and we will be solving some questions of tutorial classes. So as we discussed earlier, uh, Gaurav has also joined as a newcomer. So I will be just giving a recap of just those two classes. So suppose this is a tractor and some weight is coming on it. W. If we are just throwing this wheel, some TF is we are applying, then the ground reaction force will, suppose say G, will pass through the center of the wheel, and this is stored condition. We are just throwing, no torque is given in the wheel. If just torque is given, only torque is given in this wheel, and there is no pull, the ground reaction will act perpendicular to this wheel, and
it will not pass through the center, but slightly away from this center. And this offset we say suppose E, and this offset into this ground reaction, say G into E, will balance this torque coming on it, and this torque in this direction will just overcome the rolling resistance which is generated at the surface of this, at the contact surface between the tire and this wheel. Now third case is driving condition, where pull is also applied and some torque is also applied. Then the thrust which is developed at this contact area, suppose we say F. Then and also one say some initial resistance is coming here at this contact surface. Then the ground reaction will now not be perpendicular; it will shift in this direction, which will balance the pull and torque coming on this tire. Second, we discuss the tire terminology. Suppose this is section height of this tire. This section height. This is rim diameter, and this is again section height. Then on tire designation, generally section height is not given, section width is given, and this rim diameter, nominal rim diameter is given, and this is rim diameter. So for nominal rim diameter, we multiply with 1.06 so that we can reach up to this rim diameter. And for section height calculation, in section width, we multiply with aspect ratio, which is nothing but h by b. So h will become aspect ratio into width. This we multiply with 2, so that this height and this height we will add, and this overall diameter we will add both 1, 2 and this 3, and we will get overall diameter of the wheel. Third thing we discussed was travel reduction ratio, which is nothing but slip, which is expressed as 1 minus VA by VT. Net traction ratio, which is nothing but this pull divided by this vertical weight coming on this wheel, means pull by weight. Tractive efficiency is nothing but drawbar power by axle power. Gross traction ratio is this force total thrust generated by the wheel divided by weight coming on it. And motion resistance ratio is this total resistance divided by dynamic weight coming on this wheel. Then we discussed Viva-meter technique, in which we calculate the pressure linkage relationship, that is P and Z, and we also calculate the shear stress and displacement relationship through say annular ring or something like that. Then next we discussed how to calculate the modulus of sinkage, that is Kc, K5 and M. In this, Sivaraman, you were asking in last class, you were having some doubts. So you listen.
Using a
You
yes,
were
sir.
confused.
Let us say not possible. Now what will be the question?
You were confused in 3 plates and 2 plates, right? So
Yes,
let me
sir, yes,
discuss
sir.
this. The thing is that suppose the this governing equation, that is Baker's equation, is P is equal to K into Z to the power n. You will take log to both sides. Log P is equal to log K plus n log Z. For suppose V1, we will get some equation log P1 is equal to K1 plus n log Z1. And suppose for second plate, we will get log P equal to log K2 plus n log Z2. And for third plate, we are getting equation log P3 is equal to log K3 plus n log Z3. So this is the equation which is similar to Mx plus C. So suppose this is Mx1 plus C1. So we will draw a curve graph against log Z. This is x. We on x-axis we are plotting log Z, and y-axis this is log P. And suppose we have 3 plate, we are getting 3 lines. Suppose like this. This is log P. So if we will extend this line up to this, we will find this intercept. Then this is nothing but this is log k1 for first plate. For second plate, this is log k2, this intercept. And for third plate, this is log k3. Hence we have obtained log k1, log k2, and log k3. From MS Excel, you can also draw and then you will find the intercept. Or you can take log z is equal to, means this line we have, at this line we have log z is equal to 0, means at z equal to 1. At z equal to 1, this will be nothing but log k1, log k2, log k3. So from log k1, k2, k3, you can obtain k2, k1, k2, and k3. Means suppose log k1 value you have something, then you can get from there k1, k2, and k3. And this k1, k2, k3, if you plot on k, on will plot on k versus 1 by v, where k1 will be against 1 by v1. Okay, Gaurav is asking that what is the question? The question was that in nptel course, sir has given problem where the problem was for 2 plates, and one problem in theory he has talked about about 2 plates, and question he gave a question on 3 plates. And last time we solved a question in which there was a confusion that how to solve if we have 3 plates and how to solve when we have 2 plates. That was the question. These 2 methods are discussed. For 2 plates, sir has derived one equation, and for 3 plates, sir has given this method. So what is the relationship Sivaram was asking last time? So I am explaining this here. So for K1, Gaurav, do you are you not getting what I am saying? I am just discussing the theoretical part also. There is no question here. If you will get this method process, then you will solve any question related to this. Okay, do you have any idea about meter? This terrain response. But I'll give a brief of what is. Hmm, I will give a brief about what is this places relationship. We have some plate for from Viva meter. We place this plate beside the soil, and and our aim is to find the modulus of sink is k and exponent of sink is n. Uh, and the relationship for this nk is pressure which we are applying, which we obtain from some sensor, that what pressure we are applying. Uh, okay, I'll get that. So we have k1, k2, and k3 against 1 by v1, 1 by v2, and 1 by v3. So, and the equation which we have is k is equal to kc by b, k is equal to kc by b plus k5. So here k5 is nothing but this intercept, and 1 by v is our x-axis. So kc will be kc we are getting as the slope. Means if this is the slope theta, then tan theta will be our kc. So this is for 3 plate and this is for 2 plate also. What sir has told in us in that tutorial is that if we have 2 plate, then sir has directly taken this as some value. Sir has not given. Sir has not taken with this method. Sir is not going with this method. Sir is directly deriving some equation. We suppose this is log t, this is log z. Then sir has taken this at some value. Suppose if you take it, the intercept as log a1 and this intercept as log a2, then for this line where log z is 0 and at z is equal to 1, our log t is nothing but log A1. Log P is nothing but log A1, which is nothing but we have log P is equal to log A1, means P is equal to A1. And this is nothing but log K. This is our K value. And K is nothing but Kc by V, V1 plus K5. So from this equation also, if you will find K5, you will get some value like V2 minus V1, I think, into V1 minus V1 V2 by V2 minus V1. This equation you can also get from this curve. You will take only 2 points here. Number of plates, if you will increase, the trend line of this line will go up and down. That's the only thing. We take more number of plates. If you take more number of plates, then also you proceed with this method, A1 method, or if you proceed with this method, you plot 2 points only here and you plot it against 1 by B, you will get the same answer. So is it clear, Savan?
Yes, sir. Yes, sir.
Okay. Both method is same. At here, sir has not drawn it against 1 by K. Sir has not drawn it against K versus 1 by K. Just he has simplified and made a generalized equation. And for 3 plates, he has done this method. Both method is same. Okay. Then we to next. Next week 3, we will start with a simple question. The ruling resistance of rigid top wheel does not depend on which of the following. If you have seen that lecture, you will able to answer this question. Rolling resistance of a rigid toe wheel does not depend on which of this following factor. This is not a function of what. Sivanand answer. Have you seen those lectures? Option A is not correct. This is a rigid wheel. Some weight is coming on it. If you have seen the derivation,
Is it the diameter of the wheel frame?
you are only 2 people, so you can say if there are more number of people, then writing in chat is good option. So Gaurav, you can also interact because we have only you are only 2 people. So Gaurav, you said width. What you said, Sivanam?
Option C, sir.
Diameter of the wheel. Okay. Sir has derived this equation. Okay, no problem. You can write Gaurav. So suppose at some angle, say theta, if this is the sinkage Z and our total sinkage is Z0. Okay, you can write, no problem. Gaurav. And for this incremental theta, say d theta, we have some normal force Dn, radial force Dn. This is dw and this is dr. This dr is our resistance and this dw is the small weight coming on it. And this whole angle is theta 0. So our dn will be pressure into this dA, and this dA is the curve length, that is RT theta into the width of this wheel. Suppose the diameter of the wheel the diameter of the wheel is d, then this and radius is r, then r d theta is the r plane, and width of the wheel we are taking suppose b, then this dn will be t into vr d theta, then dr will be this dn sin theta, and dw will be dn cos theta. This, if you will integrate, then you will get r as vk z0 n plus 1 by n plus 1, and this if you will integrate, you will get w is equal to some equation is there which you can which you can always write down this. Remember, you can, if you will remember, then it is also good. Then w is coming as dk root under 2r. 2r is nothing but diameter, z0 into to the power 12 plus 1 by 2 into 3 minus n by 3. This is difficult to remember. So if this z0, if we will get in terms of w, then and the z0 if you put in this rolling resistance, then you will get the final equation of rolling resistance, which is nothing but this rolling resistance is equal to, will come as dk by n plus 1 3w by pk root b into 3 minus n to the power 2n plus 2 by 2n plus 1. So from here you can see that rolling resistance is function of what all things. This b is nothing but width, this width of the wheel. So Gaurav is incorrect. This width is the first function. This v, then b and k, b, k and n are nothing but the modulus and exponent of syncage. Modulus of syncage is k, the exponent of syncage is n. So k and n is also not the correct answer. Width of the diameter is also not correct answer. Weight coming on it is also, it does also affect rolling resistance. So weight, vertical load coming on wheel is also not the correct answer. And this d is already diameter. So diameter of the wheel is also not correct answer. So what we are left with is the area of contact. So it does not depend. For rigid wheel, the rolling resistance does not depend on the area of contact. Area of contact is the right answer. Gaurav, did you get it? Sivanama? Okay.
Yes, sir. Yes, sir. I'm getting you, but theoretically I'm getting you, but practically I'm getting immense, sir. Because sometimes we are telling that volume resistance is dependent of footprint of the power. So footprints may
This is
increase
that
or
that is
decrease
that
between.
only I'm trying to explain. For rigid load wheel, the contact area does not matter. That we will discuss in later questions also. For pneumatic tire, it depends on
Okay,
area,
thank
but
you, sir.
uh, for rigid wheel, that area doesn't matter that much. Means the width of the tire, that area term is actually not coming in the expression. That thing is only we are discussing. In the rolling resistance expression, we have B, we have B and D. The area term is B into L, or the area term is not there in the expression. That I am just trying to say from this question. Okay, if you have understood this, the next question is also related to this only. The rolling resistance of a rigid load wheel is directly proportional to which of the following things? Rolling resistance of that rigid load wheel. This is from lecture 11. I have just given the equation. From that equation also you can also observe. And if you have studied those lectures, then you should solve this question. You can answer. You can guess also. You can write in the chat box also.
Option A, sir.
A. Sure. Okay. Rolling resistance we have written like this. This if we will simplify is B and K we have here also, we have here also. For if we will simplify it in a single term, then rolling resistance will come as 1 by n plus 1, 3 by 3 minus n, 2n plus 2 by 2n plus 1, then B that is width minus 1 by 2n plus 1, into K minus 1 by 2n plus 1 into 2r that is diameter minus n plus 1 by 2n plus 1. This minus is common. Then weight coming on it to the power 2n plus 2 by 2n plus 1. So what all the terms are in negative, exponent are in negative here, are indirectly proportional, and the thing that is in positive exponent are directly proportional. So what is your answer now? This is width of the wheel and its exponent is negative. Sivaram, are you getting what I am trying to say?
Yes, sir. Yes, sir.
It will go down in this equation. Means b to the power, it will go down in this equation. B to the power by 2n plus 1. So it is not directly proportional. If we will increase b, if we will increase b, then rolling resistance will decrease because its power is negative. Modulus of increase. Do you think it is directly proportional? It is also not directly proportional. Width is also not directly proportional. Diameter of the wheel, this is d. Diameter. Diameter of the wheel is also negative power of this expression. This diameter will also go down. If you will increase the diameter, then your rolling resistance will decrease, not increase. This means that it is indirectly proportional, inversely proportional. Are you not getting? From this expression, it is clear. The exponents which are negative are inversely proportional, and only one expression that is weight coming on it is directly proportional. It is positive. It is a positive exponent. So diameter is at negative exponent. It will go down in the expression. Only weight coming on it, the normal load coming on it, is that it will increase the rolling resistance of the wheel. It is not that hard, I think. Sivaram, are you getting?
Yes, sir. Yes, sir.
Uh, you got it. We can move to the next question, right?
Yes, sir.
Okay. So for a given soil condition, this is theoretical, very theoretical question. In case of rigid torque wheel, for a given soil condition, not theoretical. This is also we have discussed right now. This we will from this expression you will be able to solve this question very easily. For a given soil condition, in case of rigid torque wheel, both diameter and width means this B and this D, or this two are you can write it D, means both this B and D will equally affect the first option. I think both width and diameter of the wheel will have the same effect on reducing the rolling resistance. Second option is width and diameter of the wheel will have no effect on reducing the rolling resistance. This is very easy. Increasing the width of the wheel will have greater effect on reducing the resistance as compared to diameter of the wheel. And the last option is increasing the diameter of the wheel will have greater effect on reducing the resistance as compared to width of the wheel. Means rolling resistance we have earlier seen is function of width, diameter, modulus of sinkage already. This is one property. Then vertical load coming on it. The question asked here is the between among this width and diameter both will affect equally rolling resistance, or both will have no effect. That is not true. We can directly omit from this question. The third option is B is having more effect in reducing the rolling resistance, or D will have the more effect on reducing the rolling resistance. So, uh, what is your answer? How these things are reducing the rolling resistance that I have described? Both are both are negative. Both are negative exponents. So, Shiva will solve it. Both B and D are a negative exponent. This it will go down. This it will reduce the rolling resistance for sure. If we will increase the P also, the rolling resistance will decrease. If we will increase the D also, then rolling resistance will decrease. So if both will affect equally, or both will have one will have more effect. Then which one will have more effect? That is the answer. Increasing the width of the beam will have more effect in reducing the resistance, or increasing the diameter will have more effect in reducing the resistance.
This is option D, sir.
Absolutely. Gaurav said it. Sure. Okay. I will see this. What was the equation we wrote in the last slide? Root resistance is equal to option D. Gaurav also. Okay, option D is correct. How you guessed, or you have any logic? Sivaram, you explain why diameter of the beam will have more effect.
Sir, I put the two terms out of that previous equation you solved it, sir. From that, I took the term along with the width and along with the diameter, sir. Then I substituted n is equal to 1, and among those, diameter gave the higher power value, sir, in negative term. So using that, I'm assuming that uh, D may be having most effect on rolling resistance.
Yes, you are correct. In this expression, if you will substitute n to suppose 1, or n is equal to 2, then what the value you will get? For B you will get less, and for D you will get more exponent. That suggests that diameter of the wheel is increasing the diameter of the wheel in this increasing wheel is a good idea than increasing the width to reduce the rolling resistance as in case of torque resistance. So we will move to the next question. Which of the following is not limitation of Baker's rolling resistance equation? This equation works well only for values n up to 1.3. This equation is applicable to moderate sinkage Z0 less than T by 6. Prediction of rolling resistance for wheel greater than 50 centimeter in diameter becomes less accurate. Prediction of sinkage Z0 in tri-sided discharge is not accurate if there is a significant slip in sinkage. This is a theoretical question. Uh, if you have seen a video once also, then you will answer this question. So you can guess also. You can write in the chat box.
What are your answers? Gaurav, if you have, if you
No
don't
idea.
want, you can guess. What is it? No idea. Okay, no problem. This is a theoretical question. This is given in book also, and sir has taught that also. The equation works well only up to this 1.3 value. This when you will derive that equation which I was trying to show here. When you will derive this equation, you will get an exponent, and that is limited to n is equal to 1.3 only. So first expression is a limitation, second is also a limitation, and third prediction of volume distance for wheel greater than 50 centimeter becomes less accurate is wrong. Greater than 50 centimeter is okay. For less than 50 centimeter, there is limitation. That is not accurate. That is incorrect. And D is correct. So this is a theoretical question. You can solve when you will see the video. Rotating resistance of a pneumatic wheel is due to. This is very easy. Sivarma. Rolling resistance of pneumatic.
I can see
Rolling
the
resistance
answer,
of
sir,
pneumatic
but I
wheel
think so it is flexing of tire bed.
flexing of tire. The the correct answer. Gaurav has told. Rolling resistance depends on flexing also, shock compaction also, bulldozing also. This is the main means criteria which affect the rolling resistance. So all of them is the correct answer. There's some problem with this screen. So you solve this question, I will do the checks. If PG is the average ground pressure, PI is the inflation pressure. PG is the ground pressure, PI is the inflation pressure, PC is the pressure due to carcass stiffness. Then for elastic mode of operation, which of the following expression is correct? I don't know what is happening with this one. So you answer this question, I will check it. Are you solving this? Rolling resistance of pneumatic wheel. We have done this. The average ground pressure is PG.
PI is the inflation pressure. Kc is the pressure due to carcass stiffness. Then which of the following is correct for elastic mode of operation? There are two cases of operation elastic mode report. Easy is the ground pressure. If inflation pressure is PI, PC is the carcass pressure. Then PI plus PC. If this PI plus PC is greater than PG, then this is said to be basic mode of operation. And if this PI plus PC is less than ground pressure, then this is said to elastic mode of operation. P. PI plus PC should be greater than PG. Yes, correct. D is the correct answer. Sivarman, did you get this? If our ground
Can you
if ground pressure is more, then that wheel is said to be operating in elastic mode. And if PI plus PC is more, means ground pressure is less, then that is rigid mode of operation. Same curve. So now you are saying something, you have raised your hand. For the carcass stiffness pressure. So this is wheel, it is filled with air, then that is inflation pressure, and this carcass is there. This will also not this will also carry some load. This only the air inside this will not carry load. This carcass will also carry some load. This carcass will also exert pressure on the ground. That is carcass pressure. This PC. Inflation pressure is inside this carcass. That is PI. If this combined PI plus PC is greater, then this will ground and it will operate at rigid mode. And if this is less than ground pressure, means ground is applying more pressure, then it will deflect and it will work as elastic mode. Is it clear?
Yes, campus pressure is due to sidewall deflection.
If it gets deflected, then it is elastic mode. And if carcass pressure plus PI is combined, if that does not allow to deflect the wheel, then that wheel will act in rigid mode. Okay.
High deflection means high pressure and low deflection is low pressure.
Yes, got it. You are saying something. You can also write. You can say. Okay, we are moving then to the next question. For same modulus and exponent of synchrase, if Corby have any issue, you can write. We will discuss this. For the same modulus and exponent of synchrase, with the same weight coming on the wheel, which of the following equation or expression holds true? This is also directly from the tutorial. This you can only guess also if you have not seen videos also. From guessing also you will answer this question. RR is rolling resistance of track. RR. Pneumatic is rolling resistance of pneumatic wheel. Net inflation pressure at carcass and the ground pressure leads or want to go numerical, then it will become more to go. See. In essence of track, if you derive the equation, you will confirm that road resistance of track is V by N plus 1 TC by T is K5 by Thank you by K N plus 1 by N. You not really need to remember these equations. And for pneumatic, it is V into PCR, that is ground pressure that we have discussed before. N plus 1 by N plus 1 Kc by T plus K5 1 by now you said C. So now do you have any answer? If you compare these equations, you will see that we have V also here, V here, N plus 1, N plus 1. Kc by V is to the same exponent. So Kc by V plus K5 is also same. Only the difference here is this expression. And this is also same. This place is the weight coming on it divided by contact area. So for same weight coming on it, the contact area of a track, T into contact area of a track is always greater. For pneumatic wheel, contact area indicates something because the length of the track is greater or is also greater. We have track length, that is obvious that this length will be greater, and for suppose some width, then this is some width is there, then the length of contact for a pneumatic tire will always be less. So this expression is developed by Br raised to this exponent and this Pgf raised to this exponent. If contact area is more, that will always reduce the road resistance to the track. Are you getting? If we have a larger contact area, we suppose area of track is generated 80, this will also be very large than area of vertical. We suppose if this is very large, this expression is very large. If this expression is very large, then this expression will reduce, and that will also reduce the rolling resistance. So rolling resistance as of track is will always be very less because area of track is always very high. So area of rolling resistance of track will always be very less than area of rolling resistance of magnetic wheel. This is the correct answer. The government didn't forget this.
Uh-huh.
Next question is also related to
Sir,
this
I'm
one.
audible.
हाँ गौरव और शिवराम
Sir, can we say that in track that traction is high compared to pneumatic? That's why rolling resistance is less in simple words.
which term is high you said
Traction is high in track compared to pneumatic.
traction is high traction resistance is less yes you can say
High traction means it's not
yes
resistance to
yes yes you
means
are
not
honest.
resistance to movement.
Yes more traction means more useful uh, gear it's more useful generator that you can also conclude
Okay.
this is just for this is just a comparison of track and rigid wheel which expression holds true for track and rigid wheel. Suppose we start with W. We take first W. Then W's exponent here is n plus 1. Suppose you take n as 1. Then this will be 3 by this will be n is 1. Then this is 2. And for n is equal to 1, this is 4 by 3. This is 2 and this is 4 by 3. So how W is affecting? Barabar. So unit resistance for same weight, the exponent of W is more in case of track. Now you if you will see the exponent of sinkage K, here this is also K, this is nothing but K only. It is 1 by n, it is 1 by 2n plus 1. It will have more effect than, and for n different n you can calculate. But for 2r, that in question also we have discussed that this does not effect depend on area. This depend on just diameter of the wheel. Oh, sorry. Is it also not visible now? Is it visible now? Is it still not visible, Gaurav? Sivaraman, my presentation is not visible to you also.
For me, it is visible, sir, with lights and
Gaurav, Sivaraman, can you write what you just said? My presentation is visible or not?
yes, it is visible, sir.
It is visible to you, right?
Yes,
Okay, Gaurav, you rejoin. Here also the same concept applies. Area of track is always very high as compared to rigid wheel. In case of rigid wheel, Gaurav, you rejoin. My presentation is visible to Sivaraman. Okay. For rigid wheel, width is limited to suppose 55 centimeter only. Gaurav, is it visible now? Okay. Here the same concept applies. So rolling resistance of track is always less than rigid wheel. If you compare rolling resistance of track, rolling resistance of pneumatic wheel and rolling resistance of rigid wheel, for track it is always very less as compared to pneumatic wheel and rigid wheel. That is the sequence you can say. So for track it is always less. You can just close your eye and you can always say that track will give very less rolling resistance as compared to animal. This is expression for shear stress and shear displacement relationship. This equation you don't need to remember, but logic. This I have explained in the last week that you can say that which expression is related to which one. For which unsaturated plane, which expression is correct? You have to say. Sivaraman, I explained to you this in last class very. What you said, Gaurav, you can write. What is your answer? For loose and saturated clay, we get a curve like this, and our shear deformation modulus K is nothing but an intersection of its slope and this slope. This distance is our K shear deformation modulus. We have only K term in the shear stress. For organic terrain, the graph comes like this, and tau max, the expression, the K deformation, shear deformation modulus is expressed as K W. And in case of compact sand, the graph is like this, and at tau max, it is Kw, and at constant uh, and at constant curve, we say the deformation as this value as K residual or Kr. So you just find in the expression where we have only K and where we have only Kw and where we have Kw and Kr both. For Kw and Kr both, it is compact sand. For organic terrain, we have only Kw and K in the expression, and where we have only K in the expression, that is for loose sand. That I have given the answer. Now you write your answer in the chat. In this expression, we have only k term. Here you can see that this is for rule sign. In organic terrain, we have kW. At tau max, the deconvolution modulus is kW. So this kW expression is for organic terrain. And for compact sand or silt, we have kW and kr both. Kr and kW. So this expression you can say is that is for compact sand or silt. So one is B, two is C, and three is A. B, C, A. B, C, A. Means B is the correct answer. This expression you don't need to remember. I just explained this in last class, so I gave this question. So Sivaraman, is it clear to you now? Okay. Now you take out your calculator. We will solve a numerical. This is very easy. If a free rolling rigid wheel of diameter is given as 80 centimeter, width is 10 centimeter, total weight coming on total weight of 10 kg is to be operated on a horizontal soil surface. This weight coming on the wheel is 10 kg. Shear deformation modulus, that is nothing but K, is 2000 Newton per mm square, and exponent of sink is at 0.5. This N is equal to 0.5. Calculate the force required to tow the wheel. You have to calculate the tow force, the force required to turn the wheel. First, A portion you solve, then we will move to the B portion. I will give you expression for towing the wheel, that is nothing but is equal to rolling resistance of the rigid wheel. Rolling resistance is given as Vkz 0 to the power n plus 1 by n plus 1. You have B, you have K, you have Z0, you do not have Z0. Z0 you need to calculate. You have N, you have only N, that is 0.5. And the expression of Z0 is nothing but in terms of W. In the first slide of this session, I explained how to calculate Z0 in terms of W. I wrote that expression, I am writing it again. This is Z0 is 3W by Vk root under 2R into 3 minus n, 4 to the power 2 by plus 1. Gaurav is in bus, I think, and Sivaraman, you calculate this. What Z0 you get? 3 into W. W is weight coming on it. Weight coming on it is given in kg. First you convert it in as weight, that is you have to multiply it with 9.8. 3 into W is 10 into 9.8. We write it down. V is 0.1. T is 2000 into root under twice dimension of the weight, that is 0.8 into 3 minus 7 is 2.5 to the power 2 by 2n plus 1 is 2 by 2n plus 1. This is 1 plus 1 is 2. This is 1. This expression, this you calculate what you are getting. This will come in there.
0.6580, sir.
What you said?
That answer is 0.6580, sir.
0 point. What you said?
0.65807.
65807. That is approximately correct. This Z0 you put there, you will get the force required to tow the wheel. That is towed force or roll resistance. 0.1 into 2000 into this Z0, 0.66 approx to the power 2.55, 5.7. This will come in Newton. What answer came? Sivan,
88.
88. 0.1 into 2000 into 0.66 to the power. 0.66 is right now.
I made a I
Wait,
made a
wait. This is coming 71. You are seeing it. 71.5. If this is correct, then 71.5 Newton is the force required to do the this wheel.
I got it. 71.498.
Okay. Gaurav, are you solving or you will just watch? Are you solving it, Gaurav?
Yes, sir. I am on the way to my home, sir.
Okay. So the second portion is if the same wheel is to be towed up on an inclined surface of angle 15 degrees, what will be the force required to tow the wheel down the slope? This is the wheel. This is 15 degrees. What is the force required to tow the wheel downwards? It will slide also. I think. Okay, if you're towing it down, 15 degrees very less. So if you tow down, then what is the force required to tow this wheel down the slope? In the tutorial, I think it is up the slope. Then you can also solve it for up the slope. We will do it for both. Okay. For moving down the slope, what is the force required to move this wheel? What is the approach? Sivaram, can you tell what difference will come? What difference will come in this question? The question is same, just 15 degrees inclination has come, then what will happen in the question?
You take the gravity in accordance with the distribution. Sir.
This the weights weight will break into two component. That is, if this is W, this will break as W sine theta and this W cos theta. This theta is 15 degree. This 15 degree. And the weight coming on wheel in this Z0 is denoted as W. So this W cos theta will now be the weight coming on the wheel. So in 3W you have to include 3W cos theta, means cos 15 degree, and you have to do the calculation. And this is one only, so you can just multiply this with cos 15 degree. You will get the new sink case Z0 new or cos 15 degree. This Z0 new you have to put in this equation Z0 new. You will get the total force. That is not the total force actual. You have to subtract it with W sine theta, because that is already there. W sine theta is already moving the wheel downward. If it is moving upward, then this total force you have to add with W cos W sine theta. You will get the total force. You will get the force required to throw the wheel upward. For in upward condition, you have to add W sine theta with this rolling resistance, what you are getting with W cos theta. And in case of moving down the slope, you have to subtract it with W sine theta. So Z0, you calculate, you have just multiplied with cos 15 degree. 0.586, 0.66 into cos 15. Zero point 0.63. 0.63. You just put this 0.63 here. You get the new total force. If you will add, you will get for moving up. If you will subtract, you will get for moving down. This is just addition. You can do it right now. So, Sivaraman, can we move to the next question?
There's one small doubt, sir.
Yes.
So, in inclination calculating, we should be changing the Z0, we should be modifying it as by multiplying it with the certain degree, sir. And then we should be subtracting it with the W of sin theta also, sir. That for further during in the end of the problem.
Miss, if the wheel is moving down, then that force W sine theta force is already acting. That is already allowing the this wheel to move down. W sine theta is allowing the wheel to move down. So for moving up, you need to add this with the total force, and for moving down, you need to subtract it with total force. That is just math. Is it okay, Sivan?
Yes, yes, sir.
Okay. A two-wheel drive tractor fitted with 13.628 tire at the rear axle has to carry a load of 15 kilonewton. The tractor is to be operated in a soil with pressure sinkage parameter n is equal to 1 and k is equal to 15 plus 20 kn to the power kn m to the power n plus 2, with both the wheels sharing equal load. Two inflation pressure 70 and 100 kilopascal are proposed. The corresponding pressure due to carcass stiffness is 20 and 35. This he will solve. Then Gaurav will understand that his doubt he was asking. Find the loading resistance of the rear wheel for both the condition. For both the condition is both the inflation pressure. You have to first check that the wheel is as per this PI plus PC, and PG you will compare. PG is the ground pressure. That is the only thing you have to calculate here. Then you have to calculate compare it with PI plus PC. where in which first condition is 70 is the pi and 20 is the carcass pressure, and second condition is 100 is the pi and 35 is the carcass pressure. This is 90, this is 135. You compare it with pg. Pg, how you calculate ground pressure? The expression is Baker's equation is P is equal to kz to the power n. So P will be Kc by V plus K5, that is K into Z not to the power n. Z0 we have derived in the first slide only. Z0 is Z0 in terms of W. Some 3W by Pk root P 3 minus n, some exponent, say something. If you will put this Z0 in this whole equation, you will get the formula for Pg, formula means expression. That will come as Kc by V plus K5 to the power 1 by 2n plus 1. 3W will remain as it is. 3 minus n is also unchanged. B root D to the power 2n by 2n plus 1. This will give you critical ground pressure. This you have to compare with Pi plus Pc. So first you calculate and you check that it is greater than 90 and greater than 150, 135, or what it comes because this is what this is coming. Kc by V plus K5 is already given, I think. This K is nothing but Kc by V plus K5. Means 1520 you directly write here. And N is 1. This is 1 by 3. 3W. Weight coming is what? 15 kilonewton. But the thing you have to notice here is that it is carrying a load of 15 kilonewton. But this is two-wheel drive tractor and with the both wheels sharing equal load. Load coming is 15 kilonewton and both wheels sharing equal load. So weight coming on one wheel is 7.5 kilonewton. 3 minus n is 2 into width of the tire. You have to calculate it from there. This is 13.628 tire. So how will calculate width? 13.6 is what? Sivaram, this we have discussed so many times. This is section width, right? And 28, this is in what, in which unit? 13.6 in inches. And 28 in inches is the diameter of the tire, nominal rim diameter. From here you have to calculate the rim diameter overall, and then you will calculate the overall diameter. Diameter is required here for T. Width is directly 13.6 into 2.54. 13.6 into 2.54. But this is in centimeter and our unit is in meter. We are using meter. So 13.6 into 2.54 into 0.01 you will do. You will get this in meter. This is section weight. 13.6 into 2.54 into 0.01. Sivaraman. Hmm. 13.6 into 0.0254. 0.345. 0.3454. 0.345. It's section width. And for overall diameter, what we do? This section width we multiply with the aspect ratio. Then we have two section heights, so we multiply it with 2. Then we multiply this rim diameter, nominal rim diameter, into 1.06 to get the overall, to get the rim diameter. 1.06 into diameter is given as 28 inch. We have to multiply it with 0.0254 to convert it into meter. We convert it into centimeter only here. 2.54. What it is coming? Aspect ratio, if it is not given, you can always take the aspect ratio 0.75. 2 into this section width, that this is 34.5 in centimeter and 0.34 in meter. What overall diameter you are getting, Sivaram?
Calculating it, 1 minute.
Calculate.
Sir, that aspect ratio 0.75, 0.75 we can take in any case, or it is defined means for agricultural is this much, or in industrial is for this much.
For tractor tires, if it is not designated on the wheel, then you can take by convention. It is 75%.
Okay.
Generally, it is given on the tire. For radial, it is generally given only. For bias ply, it may or may not be given.
Yes, sir. Yes, sir.
Sir, I got it as 127.20, sir, in centimeter.
127.20 centimeter. This is 1.27 meter, right? 1.27 root under 1.27 to the power 2, and n is 1. I think 1 is 2 by 3. This U2. This we are doing in a standard unit, so it will come in kilopascal. This is 90 kilopascal. First we will compare, and for 135 we will compare.
Sir, the final value for this is 108.309, sir.
108.309. Okay. We first calculate it with 90. Pi plus Pc is 90 is less than Pg. This ground pressure is more. Is this elastic or rigid? Ground pressure is more. And in second
No, sir.
condition, more. Pg is more. Ground, the critical pressure which we calculated is more. So it will be operate in elastic mode or rigid mode.
Elastic mode, sir.
If ground pressure is more, I told you that it is. If ground pressure is more, that will deflect the weight. It will deflect the tire, and it will work as elastic. If ground pressure is less, then it will sink and it will work as rigid mode. So the question is, find the rolling resistance of the tire in both conditions and select the inflation pressure to use. So for elastic mode, what will be the rolling resistance? Find the rolling resistance in case of elastic mode. In elastic mode, our rolling resistance formula is what? Rolling resistance is dk z0 to the power n plus 1 by n plus 1. For only sinkage, term will change. For elastic mode, z0 will be directly this one. Z0 will be what we have calculated pi plus this the list one 90 pi plus pc. This pressure divided by k to the power 1 by n. This Z0 you put in rolling resistance, you get the rolling resistance of inelastic mode. And Z0, what we calculated from this side, we will put in rigid mode because this is the formula for rigid formation. This Z0 we will put in this rolling resistance, then we will get rolling resistance in case of rigid mode. Z0 we will put only for the minimum 90 pi plus pc. We will get the Z0 in case for elastic mode of operation. This pi plus pc is 90 by k is what? 1520 power 1 by n. That's what only 90 by 1520. What it is coming in is meter. You put it and directly you get the rolling resistance. Sivaram, you do the calculation.
No, sir.
Ah,
Sir, I have doubts, sir. First, in first condition, how that it will be elastic, sir? Sir, I didn't get.
ground pressure Pg is active. Pi plus Pc is inside the tire. If ground pressure is more, the tire will deflect and it will work as elastic. And if the Pi plus Pc, the tire pressure is more, then it will sink in that. This Pg will be less in that condition. It will sink and it will work other than elastic, that is rigid mode. It will sink. Some Z0 will come. If ground pressure is more, then it is deflecting the tire. That is the basic concept.
Okay, sir. Thank you.
Only you remember.
Means if the inflation pressure is less, so it will deflection will be high, and and then it will work as elastic.
Mhm. Correct.
Okay, sir. Thank you.
So R elastic. What you got, Sivaram?
Right. That now is equal to 0.0592, sir.
Z0 you are telling, right? Z0 or RR?
Zero, sir.
Z0 is 0 point
0.59.
0.059. Okay, you put this Z0 here in rolling resistance. In this Z0, you will get the rolling resistance in elastic mode. dk 0.059. B we have calculated. This is 0.354. This is B. K is there 1520 and plus 1. You do, I'm also doing. B is 0.354. 0454 into K is 1520 into Z0 is 0.05, 0.059 and plus 1 means 2. 0.9 and plus 1 2. Uh, what answer came? See what this is right 0.91.
in cathode interval. So it is 0.9127.
That is correct. For rigid mode, Z0 will be this one which we have written, which I have written the equation many times. This Z0 in terms of 3W plus W, we get this expression. This we have already calculated. Calculate again what this Z0 is. 3 into 7.5 by 2 into 0.345 into root under 1.27 to the power 2 by 3. It is coming 9.4. This is too much. What answer did you get? Sivaram, what you got?
Sorry, sir. Unfortunately, I got a call, no, sir. I didn't get you, sir.
Okay.
Can you say that again, sir, please, sir?
Z0 we directly calculated its of rigid mode from this expression, and for elastic mode that expression. For rigid mode Z0 what we have derived in terms of that W and the, that we have written here. This is 3W by 2 into V root under V to the power n that 2n by 2n plus 1. This Z0 you will put here in the ruling resistance, that formula, the new Z which you are getting from here, you will get the ruling resistance for rigid mode. So what Z0 you are getting from here, that calculation. Gaurav, you have understood the process, that how to calculate in case of elastic mode, rigid mode. How to okay. Okay, Gaurav, you tell me how to solve this question. This is same. A pneumatic tire, this designation, the tire diameter is given 97.5. centimeter, section height 28.4, and width is also given 28 centimeter. It is to carry a load of 20 kilonewton. What to do is 20 kilonewton. Vehicle is to operate on a soil with pressure sinkage parameter E is equal to 680 kilonewton by meter cube. Two inflation pressure 100 and PI. Two inflation pressure is given. One is 100 kilopascal and second is 200 kilopascal. Compare the sinkage and compaction resistance of the tire at two inflation pressure. You have to compare the sinkage. This Z0 you have to calculate in both inflation pressure. Then rolling resistance you have to calculate in both inflation pressure. Carcass pressure is not given. You can take carcass pressure as 70 kilopascal. This is same problem, just data is different, and n is not given in this problem. But n is given. You just have to see the question carefully. See what is the unit of this modulus of sinkage? Okay. What is the unit of modulus of sinkage? This is given as kilonewton by meter cube. Kilonewton per meter cube. But is it the unit? This is not the actual unit. It is expressed as kilonewton per meter to the power exponent of sinkage plus 1, which is given here as n plus 2. Here you can say, you always write in this expression. If it is given here as 3, what does it mean? It says
N will be 1.
n will be 1. This n is also given in this question. So how you will proceed, you just tell me. I think the class is going longer. You just tell me, you can take the screenshot and it will solve at home. Gaurav, you tell me that how we will proceed with this question. Then we will end our class.
First, we will calculate Z0, and after getting Z0, we will calculate RR, rolling resistance.
That is the second.
In both conditions.
No. First, we will check the ground pressure, PGR. We will calculate the critical ground pressure. If it is greater than PI plus PC, then what will happen? The ground pressure
then it will be elastic.
And for elastic mode of operation, we will calculate sinkage as PI plus PC
0.
PI plus PC by K to the power 1 by N. This will be for elastic mode, and if it is in rigid mode, then sinkage formula will be that 3W by D root under T or something K, or that is 1 by 10 plus 1. This will be for rigid mode. First, we will check the ground pressure. That will be calculated as, the expression is there, that you can, if you have not, it is there in the video, Kc by V plus K5, that is nothing but K, 1 by 2N plus 1, 3W, this Z0 is only here, by 3 minus N V root. I need to write this expression. The thing is that first you have to calculate critical ground pressure. You have to check it with PI plus PC. Then for elastic mode, you proceed with this sinkage, and for rigid mode, you proceed with this sinkage relationship. You calculate the sinkage, then you directly put the sinkage, both the sinkage, in the single formula of RR is equal to Vk z0 to the power n plus 1 by n plus 1. This is the only formula for sinkage which we have seen in the first slide of this lecture. In this rolling resistance, for you put sinkage for elastic mode, put sinkage for rigid mode, and compare that in which condition. We have to compare also for which condition the rolling resistance is more, and you will neglect that inflation pressure and contrast pressure. You will neglect that inflation pressure because that is giving more rolling resistance. We have to always go for lesser rolling resistance, and we will choose that inflation pressure in which the rolling resistance is less. That is the whole concept of this whole week, I think. So is it everything clear which we have discussed in this session?
Yes, sir.
In the next section uh, we will have everything about week 4. We will see the concepts also, some numericals also, and traction engineering will be covered very comprehensively. So if you have doubt, you can ask, or we can end our class here. Okay, we will
Sir,
meet. Huh?
sir, there is a problem in action.
There is a problem in.
Yeah, assignment, sir. The problem in assignment 2 and assignment 3, last two problems are there on you, sir. The question is not complete, sir.
Are you saying something regarding assignment or my?
So in the assignment, sir. In the
Okay,
assignment,
what
9th
happened in
and
the
10th
assignment?
problems are not. In the assignment, 9th and 10th problem are incomplete, sir. The question is incomplete, sir.
Actually, assignment is not my part, but I know those guys. Can you tell me the exact problem which your voice is actually breaking? Can you write here in this chat box? Please write what you are saying in this chat box. Or you may leave. You can join next week, Saturday, 6 to 8. You can come with the doubts of week 1, 2, and 3, Gaurav.
Hello.
Gaurav.
Sir, this whole session is related to week third. Am I right?
This current right, means today's session is related to week 3rd.
Shiva, can you mute yourself, please? Shiva, can you mute yourself, please? Sir, this session is regarding week three. Week three lectures.
Week 3 lectures.
So before coming to next week, we need to go through lecture 4 classes, means online video. Then only we can understand. I mean, then only I can understand.
Miss, my approach is to, miss, you can understand. Miss, you don't need to watch those videos. Miss, you have just entered from week 3, but my my approach was to just make you understand. Miss, you don't feel any problem in those sessions. But if you have any problem in week 1 and 2, you can ask here in this session, 6 to 8 Saturday. My task is to solve means your doubts or any doubts related to your weeks. You can go through
Means this week means any week lecture and this session is not related to each other.
this session is related to what you said.
In every week we are having 5 lecture online. No, 5 lecture is there.
Huh.
So it is necessary to go through the lecture first, then